Okay. Hi, Olena. How are you?
Hello, Karim. I am great. I'm great. It's a busy week, a busy day. How are you doing?
Yeah, everything is fine. And first of all, I want to thank you and welcome you to our podcast, um, which is in the Middle East region. It's the fifth episode with the Confluent guys and the big names in the data field. Uh, you are the third host after Viktor Gamov and Alex Merced. We had a very nice discussions, and I hope this today we will be closing the trilogy by more hands-on discussion and solving real-world problems when it comes to the data streaming, lake house architectures, building solutions, real life scenarios. So I want to welcome you to our podcast. It would also be nice if you may present yourself for the audience and share your experience.
Thank you so much for inviting me. I listened to previous recordings. I really enjoyed your conversations from the previous sessions. And yes, so thank you for inviting me. My name is Olena. I work for Confluent. I am a developer advocate. So I help educate people on technology related to data streaming, data processing, data governance. And I've been in the field for some years right now. I come actually from engineering background. So I have been a software engineer for, over like almost 2 decades. And now working with data, I really enjoy it. As we were chatting before the start of the recording, is like there are so many things happening, so it's never boring. It might be a bit overwhelming, but it's never boring.
Yes, yes. I think it's maybe before the hype of the data, software engineering was really uh, uh, challenging part, but with the data evolve now, I think it's even more challenging working on data, building or solving data problems, streaming. It's not anymore uh, doing some business logic and writing it to the database and reading it from database. It's about connecting dots and connecting data from different sources, which is quite challenging, and connecting many aspects of software engineering, not only the software design or system design, but also distributed systems, data storage and retrieval, data modeling. It's quite challenging, and also networking. Maybe a data engineer come up with or came across the networking problems, security. It's kind of in the eye of the storm.
I totally agree. I actually feel that so data was always part of the equation. However, we get new possibilities to work with data. We get with new possibilities, we get new expectations and new responsibilities. And with that, the complexity increases. So if we are thinking about some years ago, so for example, I remember I was researching online analytical databases. They actually arrived back in 80s, but we didn't have that amount of data, and we also didn't have that those powers to process data fast. Right now, we can do a lot of things, and with that, we need to take care of a lot of other things which are related to how much we can make sense of that amount of data with all that processing power we have.
Yes, yes, I totally agree with you on this, Olina. Uh, okay, without further ado, let's start with the some opinionated questions. I asked the my previous guests about it, and also would like to get your input on this. Is real-time streaming actually replacing the batch processing, or we're still living in the hybrid world using this and that? And do you think we will really move to fully real-time based system or based engines?
So Yeah, this is very opinionated. In my opinion, and this opinion is solely mine, that we are using both sides, and actually, when we use both sides, we benefit from both worlds. So obviously, if we need low latency, think like fraud detection or some decisions which you make based on the transactions or operational data. You want to have real time. You want to have event driven architectures where you are exchanging the data. It will not work in batch. um, you might want to have, for example, continuous aggregation data processing where you are doing the sliding or tumbling windows, and then for example, total trades per symbol you calculate for the last 5 minutes. So you have to have the data streaming there, which happens in real time, and you need to do it as new data appears, and you need to take it into equation. However, some things we still do on demand. For example, some revenue reports, like yearly revenue report, or machine learning training. Some of that, and probably biggest part of that, happens as a batch because we have the data, and then we train the model. Some historical corrections when we reprocess, for example, data, make some schema changes on historical data, some other daily, weekly, monthly operations, they might be done as a batch, and batch sometimes is easier to reason about, so it doesn't go outside of the story completely. um, However, for a lot of use cases, um, streaming is becoming the first type, the citizen, which actually is way more important, because a lot of decisions you need to make in a moment. But often we combine both. We can even do some, for example, processing and calculations in the moment, like streaming for immediate data, and then do some batch for corrections later. So it's those things, in my at least picture in my head, they exist together. However, we shouldn't really confuse those. And for example, the problem arises where companies use batch where they should have used streaming, and that's the issue. But there are still will be use
Actually,
cases.
yeah, actually, I 100% agree with all you mentioned, and the last part, which is the core problem, whereby we're not, from my perspective, both will continue together, but it's all about when to use what. So maybe using real-time streaming because it's trendy, it's hype, but we don't need real-time streaming. And the other way around, batch processing is easy. It's we all know how to do batch processing, but the use case we're trying to solve, it's not a batch processing based problem. So I think it's all about understanding the nitty gritty stuff under the hood to decide when to use what. Uh, for the audience, also, I think this session will be a little bit different because we will not be talking about the theories a lot. We'll jump into the a saga story that we'll discuss about a real problem, and we'll try to challenge ourselves on how to solve it from building a proper data stack. And Olena will show us a really nice demo with Kafka, Flink, and Iceberg at the end. So stay tuned. Okay, right now we have the iceberg things rising very very fast and using lake houses. From your perspective, Olena, why would we use iceberg since data warehouses, the traditional data warehouses, is working fine? What is the trigger to shift from normal warehouse to lake house using iceberg?
This is such a good question. And I also liked what you said before, that we need a kind of a need for, like, a reason to use certain technology. We shouldn't use a technology because it's very like a hype, or it's such something which everyone is using. That's why we also need to use it. this only brings problems. So the case where we want to shift and start using a lakehouse instead of a data warehouse comes from the requirements of something like hitting the limits of the setup which we have. For example, we have Kafka, we have data warehouse architecture. However, maybe the data warehouse becomes a bottleneck for mutable data which we store there. So if we store there on the large scale and we also have mutable data, we have huge volumes of appends or updates, we have late arriving events, we have frequent reprocessing or backfills of whatever we have there, we might consider that yes, we data warehouse solved an issue before, but right now we need something which will help us for more complex use cases. Then another requirement which might appear is that we need something else apart from SQL. We need some kind of other engines, some more flexibility, because we have different teams now. We have ML team, and those Python people, for some reason, they actually don't want to use SQL anymore. I won't blame them. And then we want to have this flexibility, what we use, Spark, Flink, Trino, DuckDB. So with Iceberg, we will get the flexibility. And also with data lakehouse, we have this nice mixture of real-time data and also this kind of batch size or like data storage
Yes,
analytic size. So it kind of starts.
the best of both worlds. Yeah.
Exactly. It just fits better to each other. So
But so just to continue on the point you mentioned, so it's not only about the technology itself, but also for the convenience for all the teams to use the Iceberg. It's
exactly.
convenient, right?
Exactly. It's actually we need to convince developers to adopt technology. I mean, it's often as engineers we also get decisions from the top, but generally in majority of the cases we still, as a team, we will select the technology with which everyone can work in an efficient, productive manner, and can use the tools which will make our our work more like work easier, faster, and bring better, bigger difference to the
Yes,
table.
yes. I 100% agree with you, Olena. So moving forward, in order not to save the time for the hard part and the hands-on part, so over the past few years, from my side, I've witnessed many projects moving to the streaming, the event-driven architecture, the lakehouse architecture, and they failed miserably, unfortunately. From your perspective or from your experience, since you witnessed lots of projects with the due to the nature of your job, is it a tech? Is it a culture? Is it an architectural choices? What are the common pitfalls?
Yeah, so I know that in the previous edition, Victor was mentioning culture, and I totally agree. Culture is a big, and I think that the people aspect plays a huge role. However, I think another issue which I see is the architectural one, is where we tend to over-engineer. Again, to add all the trendy parts without really mastering the basics which we need. And then we will have too many moving parts in our architecture and no stable foundation. So we can lack such things as schema governance, some topic conventions, event versioning, so some strategies for consumer groups, and the lack of that solid foundation then ruins everything which we built on that foundation, because we don't really have a good holistic picture of our system. it becomes like from that Harry Potter where they had this borrow like a house where they built pieces, and it's kind of like it's only works because of magic. But in real life,
Yes.
we don't have really magic because we realize that actually everything falls
Yes.
apart. So I think that it's quite important. I think those teams um, who start maybe with one high value use case instead of trying to create a very sophisticated platform from the beginning. They start and they polish their skills with one use case. They enforce schema governance from day one. They build a minimal, boring, but proven architecture, instead of kind of trying to combine a lot of things they don't know. They kind of they grow their expertise piece by piece, and this is actually depends on the team, because some teams are lucky because they have more experts in the team. But then when you're thinking, it's not always the case.
Yes.
um yeah, data
Actually, and I add to this. It's there are two parts. I always say to the teams that I work with or I consult, the hello world works on only on your machine, but it won't work on production. When you try a Chinese technology and try to run the hello world end-to-end flow, it will be super fast, super blazing, it will be super easy. It was built for this, but it was not built for solving your problem. You need to understand how things work under the hood. As I usually took this also with the software engineering team when they are moving from monolith to microservices. It's not about the splitting the business into multiple services and they are start to communicate with each others over events or over HTTP requests. It's about the other thing, resiliency, how we will handle retry mechanism, how we will handle scalability. There are lots and lots of aspects behind the scene other than just splitting the code into another service and calling it. I think this also happening in the data world. It's not only event that I push it to Kafka and consume it from the other end and things are working. No, as you mentioned, governance, data quality, schema registry, versioning, lots of things that was overlooked. So Hello World don't work on production. So please make sure of this. Okay, so do you think when moving or taking the decision of moving to lake house architecture or event-driven architecture, this will be the last question, and we'll move on the saga part. Do you think it's beside the technicalities, how the impact, how the business would be having a say on this decision? Do we need to take the business say on this or no?
Oh, that's as an engineer, when it comes to business questions, it's only speculation from my side. But I actually believe that we need to have agreement with, so because business decisions, uh, understanding the business model actually affects how we create that data model for our system. It's like maybe going to granular, but in general, like what will be the architecture, what will be our limitations, what is our kind of ambitions for like the next year. Of course, we don't want to over engineer something, but we also don't want to under, because as you said, hello world doesn't really work in production. So I think that going hand in hand with business people, and understanding each other so that they understand our challenges, the engineering side challenges, and we understand where they want us to be, it will help to build a better system.
I agree. So it's not about running after the hype or the shiny technology. You need to understand the business goal. You need to make sure that this is perfectly aligned with the business need, as a shift in the business goal or the business need might totally change your decision of this technology or the architecture you're selecting, right?
Exactly, exactly. And I do feel that sometimes, and actually lately with AI, especially we see how much stakeholders have a huge influence on adopting um, technologies where potentially they are not needed. This is actually the common topic where I see that products, amazing products, instead of kind of fixing issues and improving where users demand improvement, instead they add some, for example, AI feature. We shouldn't follow that actually anti-pattern. Instead, we actually should have this agreement, and we should so maybe there is like several actually parties. There is like our engineering department, there is a business side who wants to grow the product somewhere, and there is also users of the system. And those all the needs should be combined and taken into account how exactly we build the system to make the best out of it.
Yes, I agree. So it's the hard part time.
Okay.
So how would you like to share the screen and walk us
Maybe
through? And
you
I'll
share. How about you
okay,
share the screen? It will be
okay,
easier.
okay. Let me share my screen then. Let us explain to the audience first the role play game that we'll try to do, and will hopefully please the audience interact if you have any question. Basically, in the architecture books, they used to have the saga pattern of proposing the problem and putting the problem in a context and try to solve this problem throughout the book. It's a well-known approach for writing architecture books. So we decided, me and Olena, this session to make it this way. So we will discuss a real use case or a real world problem, and we'll try to break it down as we go by problems we face, questions we will ask to each other, and come up with proposals on these problems. Again, disclaimer: we're not solving the problem for your or we're not proposing solutions for your problem. We're proposing solutions for the problems we're discussing here. We're not getting the full context, so it's kind of, again, it depends. All the architectural decisions or architectural discussions, it depends. You need to know more context about your problem to come up with the proper solution. So, okay, since we're in the middle of the peak sales season for the November, the White Friday, as we call it in the Middle East. So it's lots of e-commerce are facing challenges, increased numbers, systems are going down, operations are struggling with the showing numbers or serving the clients. So this will be our saga, and I'll try to be acting as kind of software engineer coming with problems, and Olena is the data architect and expert, will come up with guidance or guide me on the decisions, and I'll come up with questions she will answer. And again, she's not obligated to answer all the questions, as we don't all know the answers for questions. So yeah. Okay, so the first part in our saga, which is the crisis part, unfortunately, the flash sale meltdown. We're getting stocks showing counts that are available and checkout fails, dashboard showing incorrect numbers, payments get processed but no order placed. So we're getting a very, very frustrated clients. So Olena, from your perspective, how do you see these incidents are realistic? Is this something that you came across with before or not happening?
So, this is very realistic. I was lucky. I don't know many kind of customers or clients with whom I was talking who were describing this issue. I feel that maybe they are at the level where they are no longer making architectural decisions which lead to this issue. However, this scenario is quite realistic, where we have the misaligned sources of truth in our systems, where we have maybe several teams who didn't agree beforehand which event was supposed to do what. And then we have some domain modeling shortcuts made and we don't have enough analytics and monitoring. We have some issues maybe with dual writes, where we write something into the database and then we send an event. So then maybe something doesn't really, we don't notice an issue till, for example, Black Friday comes and our product is actually quite popular, and then with that load, all those issues accumulated in our architecture are actually starting to pop up. So this is quite realistic, sadly, also quite preventable.
Okay, perfect. So we will find some solutions for these problems as we go. Okay, so the team started to trying to understand what's going on, what's happening in a kind of troubleshooting, having late nights working at the office, troubleshooting and debugging the data pipeline and the problems coming from. We come up with four truths or facts happening on the system right now, which is we have order legacy CDC or change data capture happening because we're using an old e-commerce platform, a SaaS solution, and we're hooking into the database directly to pull all the events coming from for the BI team. And we have a checkout events for the recommendation team, a recommendation engine model. Also, we have payment events from the payment service provider that we're integrating with, and this is serving the finance part. And lastly, but not least, the marketing events for marketing SDK integration about the conversion rates, about targeting the customers, so on and so forth. From your perspective, we have partial truth here, whereby different teams building their own data models that is completely true from their perspective only, but not from the business perspective. How teams should build a holistic point of view and how to avoid the partial truth.
Yeah, this actually indicates this cultural issue in many, many companies. Here, for example, we have definitely, at least with this idea, we have around like 4 teams, and they have different goals, and they maybe use data a bit differently. But the question is, do they actually align on the life cycle of the whole order purchase process? And I think that they should sit together, and they need to understand vocabulary. So what each of those events definitions mean. What is source of truth per question, so that they are not working in isolation, but the whole picture, the whole canvas of the events is shared. Also to define who is the owner of what, so that we have kind of shared understanding of event contracts and ownership, to prevent those partial truths from appearing again.
Yeah, yeah. So it's not about as a microservice owner, I just publish the event and I run away with my hands clean. It's your problem to handle these events and the consistency of these events when it comes to the big picture. So it's not only about just publishing event from your perspective as a service, but also you need to consider the full picture or the saga of your business event, how it's relate to the business. You need to integrate with someone else. You need to make sure that you're aligned with another service, right, Olena?
Yes. So, and I totally agree with you. I think that if, for example, we have this system which publishes an event, um, it's totally acceptable that the system will be the owner of the event. Um, but they need to maintain this ownership by not screwing up everyone else who are relying on that data. So they still need, for example, if we know that business evolves, data evolves, so the event information or something will change with the time, and that particular service is responsible for that change. However, it still need to exist within a bigger picture of everything else consuming those events, and not getting unexpected surprises when something changes. So yeah, so there is, it's quite complex, of course, like to have those teams to agree on that life cycle. But I think this is where, without them collaborating, um, agreeing, for example, what order completed event, for example, means for the business, they will not be able to move forward and make things work.
I agree. And I think down the line we'll come up with maybe a kind of a solution or a pattern to use where to solve these kind of inconsistency or misalignment between the teams. But let's continue. So the root cause analysis, as we mentioned, is the CDC lagged 20 minutes for the order legacy system. Checkout crashed for whatever reason. The service was unable to recover from the traffic. However, the payment was working fine. That's why we're able to deduct from the credit cards of the customers, but we're not able to complete the orders, and marketing service getting duplicated events. From your perspective, where I'm as a software engineer working on this, where should I start, or from where will I start to solve these kinds of problems? It's a little bit overwhelming.
It is very overwhelming, and I think that this is where I would define this business contract across the teams, and this is where we again share the definitions, so that the teams, like again coming back to that order completed event, it can mean so many different things for different teams, and we want our marketing team who are using these events for some particular purpose, to get enough like information from that event. We want it to align with the payment team, so that everyone knows what that event actually means. So we start there, we align everyone on that business contract. Then we need also to have an owner for that particular event. For example, so this is again where the owner shouldn't screw everyone out later, but in a given moment, if you have some particular service responsible for that event, so like owner of the event, everyone else will consume it, but they will not redefine that event. So that we have kind of this stability of things, and it's not like everyone tries to adjust data for their needs, because if they try to adjust data, that something is not really working well with aligning on the data. And once we have that clear life cycle of how the data, what the data means, those pieces of data, how it moves through the system, then we can move to designing a clear schema to build some kind of economical stream. And then once we see that that works for our marketing finance, that they can consume that stream and use for their purposes. Once that is in place, we can add schema registry and governance to protect it, and slowly simplifies the mess which we had before. So we don't want to have this big bang, and we also don't want to skip those steps where we are starting with the common understanding, because if we just from the start try to add schemas, registry, we will just end up with, in this case, four better documented partial truths, but not really aligning the whole picture. So we want actually to work more like on this whole picture aspect. And then we put all of the registry and a schema into place. So
Yeah.
that's how I do it. Yeah.
Yeah. So this bring us back to the point that we mentioned before, which is the business goal. So defining the business boundaries is really, really critical and crucial. It's not about the microservice structure, it's about the business boundaries and the what does the complete order event means for the business. And this we can design the business domain or the data model around this domain, right?
Exactly. Yes.
Yes, perfect, perfect. Sounds good. So I think we're now standing on a stage where we identified the problem or we faced a problem or an issue happening on our system. We tried to drill down and see where the issue is coming from, which is uh, a partial truth where the data stands, and we're trying to find the root cause analysis. Why are these uh, partial truths data or truth data is there? And this was coming up from the root cause analysis. We'll move to the part two, which is the resolution or solution. You can name it. It's not the actual silver bullet to solve the problem, but it's kind of brainstorming on how we can pick incrementally this problem. We mentioned before that the canonical event design is really crucial for this part. Domain first thinking, it's about the business approach. So as a software engineer, uh, trying to get support from Olena. So I come up with I need to work on defining the business event, defining the end-to-end business event. What does it mean when it comes to the order completed action to the business, not to the microservice structure or to my team. Uh, Try to as much as we can schema event and canonical definition for events. So if I'm going to design this, Olena, what are
Mhm.
the design principles from your perspective I need to consider or to be aligned? If you give me the task to implement this or consider this with the four microservices, what are the design aspects you need me to consider when it comes to the canonical events?
So I think the key here would be that events should be those contracts between domains, not just stuff which happens. Um, and I reinforce what you said before, that we want to think about business meaning, business semantics into the events. It shouldn't be some just data packages flowing around. It
Yes.
should be the events which make sense from the business perspective at that given point of time. It's very possible that later we are going, the business will evolve, there will be changes, and we will evolve the system. But having that business semantics in place, it will help us also to understand the current situation and modify it for later. So I would focus at that as a main key point.
Okay. Okay. Uh, do you have uh, any pointers when it comes to the versioning? We come up with a stage with a state whereby we have multiple events happening, or the same event has multiple data model from the same microservice. Uh, do you have any kind of tips and tricks on how to stop teams from going to the dark with this part?
Yeah, so I think that this is where schema evolution is quite important, and we need to have a schema for the events, and also definitely the events, the information within the events will be changed. So we need to be ready to that, and then it will really depend. So we have the producer of the events, we have consumers. We want them to be on the same page, and also for the consumers to be prepared that whoever produced the event might have changed that semantics, and consumers are ready. So again, schema registry, setting up the schema so that it can be evolved, that would be something I would keep in mind. And also, this is something also to keep in mind, is that it's unavoidable that there will be new versions of events happening later with the evolution of the system.
So you don't recommend at all, if I'm communicating between the services or the microservices with Kafka or events, it's not recommended. It's risk to communicate with plain or unstructured messages between the services, right?
Definitely. It's kind of easy for prototypes. This is goes into that hello world examples. I love JSON. I totally love using something very simple, and Kafka at the end of the day doesn't really care what you send. It's like binary here. So
Yes.
but we as a humans, and we are thinking, because it's always like someone will produce the data, someone will consume, process the data, produce it again. So there is this movement of the data. It's like a web, and it's so easy to make that web a mess. And that's why we don't, like, once you just send random structures of the data and no one is controlling, do you have a proper parameters in place? Is there like something, what is the type of that value in that event which you expect? Should it be integer or can be a string or something? So you are losing control of what is happening in the system. We even have, in a way, this is connected to a term which is lately is very widely used, shift left, which means that we need to start taking care of the data quality, data structure closer to where data is
The
produced.
source. Yeah.
So yes, exactly, closer to the source, so that the producer, for example, who is producing the data, already should verify that the everything is according to the schema. And then later, when the data gets somewhere, that if there are some parameters, like some properties are missing or something else is not aligned with the schema, then we raise some kind of an issue alarm. So we figure out what is happening. Actually, we want to prevent, we want to have predictable data structure throughout our system.
Okay. And I think also, Olena, correct me if I'm wrong. Um, it's not a point-to-point communication. So I'm not sending the event to exactly one service. It might be broadcast to whoever want to listen on this topic and consume the data. So I'm not doing a custom contract or a custom data model from point A to point B. I'm just broadcasting, and whoever want to listen on this event can read the contract from the schema registry and abide to this contract. So I'm not um, just calling an API, a REST API that we agree on a contract of request and response, and that's it, right? It's a little bit different when it comes to data.
Totally true, totally true. And even so with this use case which we have here, we have the team who is responsible for payment processing. We have the checkout procedures. We have orders, events, marketing. All of those services might be using the same source of information, just for different purposes. This is the beauty of Apache Kafka. So we send the data to Apache Kafka topics. The data doesn't expire. I mean, it's actually, it expires with the time or the size of the topic, but it's not like with the queue where we read and throw away stuff. No, the
Yes.
data stays in the topic as long as we need it. And many services can access the data. We can replace the data if you need, and do a lot of different things. The same source of data, but numerous different applications with that
Yes.
data.
Yes. 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 So I think the one of the problems that I totally understand from you now, that might lead to the previous issues, is the lack of data consistency, lack of agreement on the contract of the data between service, and the most important one is defining the business event. I just recapping in order to step by step, as a junior software engineer, let's say, I'm trying to make sure that I understand the problem quite well by every step. Okay, so I think, let's say we have this kind of business domain clear, the schema registry in place, the boundaries kind of start to be formed. Now we might be getting to a more solid Kafka layer or a staging layer, whereby we might or will be able to consume these events via Flink or Kafka Streams job, building the joins and see the beauty of Flink or Kafka Streams joins the events from the source topics, doing deduplication, enrichment, and emit maybe a more solid business events. Being that said, do you think it's correct to centralize these business logic in the streaming layer or the layer of processing that's putting something like a listener on all the signals coming from the system, and this layer is doing the magic of unifying the business events, doing the cleansing, business enrichment, so on and so forth? Or should it be on the upper layer of the service, which is the shift left kind of approach?
Yeah, so ideally, uh, this is how we work, for example, with microservices. You actually trust that service to make the important decisions, and you encapsulate those decisions in a service. However, depending on where we are in our data streaming journey, and if, for example, we have with this company, hypothetical company, I guess that we don't want to have a big bang rewrite everything from scratch. So we need to do it stage by stage. And for this particular use case where we have a big mess, maybe using the central point to correct the logic at first might be not the worst idea. However, what we want to aim is that we actually separate those concerns and we have a clear owners in our architecture, because if we keep everything in the central place, all the logic will be in the central place, we actually end up with a monolith again. So we are not moving into more microservice architecture. We have in a monolith where again it grows, it becomes difficult to make sense of. So we want to aim in the end to move into having this architecture where each part is responsible for its own logic, and they communicate with each other.
Okay, but let's say, Olena, if we have the payment service provider or the payment service, the stock and warehouse management, and the checkout experience or the checkout that consolidate all of this. Uh, from software design perspective, there is the saga pattern, not the saga that we're trying to explain, but the software saga pattern, whereby I can put all the actions in a central point, and this central point calling the service back and forth, and based on the response, I can continue in my story or the saga. When it comes to the event, if I'm communicating with asynchronous communication using Kafka, where this saga can be added, or each service will send an event and process the event and push it down the stream, and there is a complete order service maybe listening and doing the joins and deciding on the final decision. uh, from your experience, which is the better approach or the best approach?
I think the sad reality is that the answer will be a frustrating one is like it depends. I I think it really we don't we want to have in the end architecture which is manageable and understandable, and I prefer where we have like if you are thinking about microservices, if we really can make sense of the moving blocks in our architecture. However, depending on the situation, the architecture of the system can be totally different. I think the goals remain. So we want to make it transparent for people. For example, you have new engineers in the team. They shouldn't be like totally in shock trying to figure out the system. It should be logical, and also there should be also easiness to add new features into the system, again, so that when we add something we don't have to rewrite everything and we don't have to deal with a big monolith. That's why I am kind of against having a big monolith, even though for some systems it does work, right? So yeah, sadly my answer would be like it really
Yes,
depends.
yes. I think actually this is the this was expecting from you to answer, which is that's why I put the disclaimer at the beginning. It's very hard to answer these questions. Maybe we can come up with tips, pro tips, do's and don'ts, some kind of patterns and anti-patterns to follow. But it's not about giving you the silver bullet of how to do stuff. It's really important when it comes to architecting software. It's not as straightforward as just writing the code and doing some business logic.
Yeah, and it
Yeah.
will really depend also on the size of the project, on the size of the team, how many teams we have. Of course, it's easier when the project is smaller, but even then, people do the shortcuts. They ignore, for example, schemas, or they think, how can I do something faster without adding some governance layer? And then they end up in the trouble. So, but in general, I think that the goal is to do the goal. Maybe it's kind of a bit um, ambitious, but how can we do the maximum with the most transparency and ease of the change? And it will depend on the project. We want to have yes, like clarity on what is happening. But again, once the project grows, sometimes it's not. It becomes more and more difficult.
Yes. Yes. I agree. I agree. Um, I think we're moving. What about the? Yes, I forgot this question. W- how would we deal with the late arriving events if we build these streams and things are moving fine or working fine, but we for whatever reason, latency, traffic, surge, whatever, we're getting late arriving events. How would we deal with this?
Um, uh, this again depends on how essential those late arriving events. Maybe for some use cases, I don't know, like you have a tracks moving on the road, and then you are sharing the location of the track. Maybe the late arriving events, it's like they no longer have any significance for us, and we can ignore them. Versus in other cases, they are important. So if we can ignore them, we just ignore them. But if they are important, we keep the window. For example, in Apache Flink, if we are thinking about the tumbling windows or sliding windows, so we will have also something which we call watermarks, and we are going to give a bit of time for the events to come later, because
Mhm.
maybe our IoT device I don't know, like restarts or whatever, like, or we have delay in the network. We want to catch those, but we give a limited time. It's not it's bounded, so it's not
A grace
infinite.
period, a kind of a grace period
Yeah,
for late
exactly,
events
exactly.
to join the window that they're supposed
Yeah,
to be.
and if it comes there, we get it. If it doesn't, then we either ignore it again, or if we are not supposed, if there is a use case where we cannot ignore it, then we need to store it, and we need to figure out. That will depend really on the logic of our system. What exactly is the best to do with these late arriving events? But with the technology, with Apache Flink, for example, we have the support to define that grace period, as well as to collect those late arriving events and send them to another source.
One of the things that I came across previously with the but Kafka streams, not Flink, about the late arriving event or the grace period. One of the developers told me, why don't we keep, if it's a critical event, why don't we keep the window open for 24 hours? And it was on staging, and I don't want to give him the answer right away. I told him, let's try it and simulate the traffic of the production. The service started to restart every now and then for memory as the window kept open for 24 hours. So it's every window you open it, it's still open, and Kafka streams don't close it. So the memory pile up very, very fast. So again, you have to choose between uh, memory, CPU. The business is very, very crucial for this part to take the decision. We can keep the window open infinitely, but you need an infinite amount of memory and resources.
You're
So
totally right. And also, I think also we often, in those situations where we have real-time data, we also do some data processing. And the data processing will actually often depend on a window, and we sadly we cannot really wait for 24 hours often for making the calculations on the new data. If we could, then we could use also, I mean, batch processing, but uh, we want to
it's
have some
it
predictability.
beats the purpose of the window processing.
Yeah, exactly, exactly.
Yes. Yes. Okay. And the third part, the finale. So, where Iceberg shines, we have things are moving fine. We're able to build the business events. Things are kind of much more stable, not in the best shape, but much more stable than before. And the business hopes for more analytics. The machine learning team start to his eye gaze about the things are more stable about the data. Why don't we benefit from this? So we started to think of mixing the, as we mentioned in the very beginning, mixing the historical part, the fast ad hoc queries, the machine learning, the BI teams start to they want to build more solid use cases. So, would you think if I come up with the proposal of using Kafka's and Flink, then Iceberg, and any query engine like Trino, Spark, DuckDB, and I want to keep a part of the discussion about DuckDB specifically, but maybe at the very end. Uh, would this be a good approach? And what Iceberg buys us over the traditional warehousing? I asked this question at the beginning, but uh, if you would shed a light on this, why don't we use something like Parquet files on S3 instead of traditional warehouse?
Yes, so this is a very important question, and we can send data into Parquet files on S3, but then what happens with the evolution of the schema? And then, for example, if we send for every event a Parquet file to S3, then we get a bunch of files in S3. We actually will have to implement something, and there are some technologies which already allow it. But where Iceberg stands up is that it allows us a lot of features, um, on top of it, it kind of like Iceberg, in my opinion. It allows us to combine the advantages and the strengths of data warehousing and data lake. So it allows us, for example, to be able to do the row level deletes when we need for GDPR. Like in Europe, we might be able to request that the data for a given customer is deleted from the database. Then we might want to travel in time, and Iceberg helps us to provide all those features using the metadata files, also doing the compaction of those files later, to take care of the performance for the queries, and also the power of Iceberg over other technologies. It became this technology which a lot of big players adopted. So we have a technology where you can bring the storage, you bring the query engine, um, uh, and you can be flexible which storage you use. Do you want to store it in S3, or you want to use some other cloud for that? Which engine for queries you want to use, whether it will be Trino or Flink or Spark. So this flexibility and the whole community which united around this technology is the biggest power of Iceberg, because we have a technology where the big players, they don't fight over like their offering, where they want to adopt like AWS technology or Google stuff or Databricks. They all actually totally fine using Iceberg, and then you can have this flexibility on selecting tools which you prefer for
Yeah.
solving the problem.
Yeah, I think the most one of the things, not the most, but one of the important things that you mentioned is separating the compute from the storage, which is a really critical part,
Yes.
which is not there in the traditional data warehouses. And the query engine paradigms are very vast, whether using Trino, Spark, DuckDB, uh, Apache Pino, uh, Dreamview. There are lots and lots of query engines that can hook on top of Iceberg, and each might be fitting a specific use case or a set of use cases. So this enables us with a very vast uh, bouquet of options to use between the different query engines, which I think it's really critical. But again, it drills down, it boils down to the your business use case. You might not be needing something like Iceberg, or the complexity comes after it, after using it. Uh, Traditional warehousing might fit if you're a small business. You're not in a very a dynamic microservice. You're not in having too many data sources. So it's really critical to decide based on your use case and
It's
business needs.
true. It's true, and even for this case, for smaller projects, I would still recommend Iceberg. I mean, it's very
Okay.
true, because there can be some situations where you want. I think for data warehouse, those projects which already use data warehouse, they need to evaluate how much effort they will need to put to move to the lake house. Um, but for those who start from scratch, using Iceberg allows them later change the query engine, the storage. So it's kind of allows them flexibility from the start, or like not really change, for example, but add. They have some
Yes.
new team which needs to approach data from a different angle, and that may be a good solution for Trino, or I don't know, like, but then they can plug in this new engine without actually migrating or putting some extra effort of shifting the data somewhere.
Yes.
So that's why actually, like for those who are starting from the empty page, I would recommend Iceberg totally.
Okay, so it increased the maneuverability of the decision of or changing the decision later on of the query engine without doing a big bang change of the analytical layer.
Yes, exactly. And flexibility, or flexibility is a huge benefit for
Yes,
any project. So
yes,
things change, and that's
yeah.
why flexibility. That's again, this is like a huge advantage of.
So based on your recommendation, so you might see in few years or maybe less, couple of years, that the go-to option for building a small warehouse or a data warehouse, it will be the vanilla approach will be the data lake house using Iceberg.
I think so. I don't know, and I am curious myself because maybe like several years ago, I wasn't thinking that iceberg becomes a huge deal. However, again, I think the success is in the community and adoption again
I
by
agree.
big players. This is
Mhm.
where iceberg just the king right now.
Yes.
And I don't think that its popularity, because a lot of companies are invested in iceberg right now,
Mm.
and that investment will remain, so I don't see it going anywhere, and I can only predict that the popularity of iceberg will only increase.
Okay. Okay. This is a big one, I think, and I agree with you on this. I agree. Okay, before moving to the last part of our session today, which I'm really enjoying, Olena, which is the hands-on part. Uh, so I think you answered the first question. So starting from the first day of the our big store, the hypothetical e-commerce platform, I think Iceberg would be the a good start. So what's the one architectural principle teams underestimate most when building streaming system? What is the key pain point since you're a dev advocate? What is the pain points you see from developers trying to adopt the event-driven architecture or streaming uh, frameworks?
Oh, there are so many of those issues. I think that lack of understanding the whole picture, or for example, assuming that data streaming that you just do and forget, and it's not the case. It's more like um, this is once you start using data streaming, um, you need to be in the data streaming mentality, or like to continue operating in that mode. Um, and a lot of people, they don't have the bigger holistic picture of their system. They're like, yeah, something is the data moves somehow. But the data streaming also requires this responsibility of observing what is happening with the data, how it evolves, of looking at the governance, at the schemas. It's not something. It's actually neither with other technologies. We just not build something and forget about it. Um, but the same is for data streaming. You need to have a control on the system once you build it.
Okay, so not being amazed by how streaming is really nice. You need to understand it's not about getting things up and running from day one. You need to maintain it. You need to understand uh, the what I call the sidecar of the data streaming, which is the scalability, the data modeling, the business. It's not it's it's a main point, and there are lots of things around it, which is we can call it metaphorically the sidecars. So you need to understand the sidecars of streaming to make sure that you're
Yeah.
in control.
Yeah, exactly. It's like the data streaming platform, for example, Kafka becomes your backbone, not really something which comes in addition. It's you need to live this life of data streaming
Yes.
for it to work how you expect.
Okay. So I think we have maybe a kind of 20 minutes. I think the last question about how Kafka and Iceberg together change the way we think. I think this you might be able to show us in the demo, maybe using Kafka, Flink, and Iceberg.
Let me share my screen. So,
Let's
and
stop
I will actually
my.
let me just see. Okay, I tried from time to time to refresh my interfaces here while we were speaking because I was like, oh, there will be like timeout and
Yeah,
logging in and setting up. Always a bit of a struggle. But let's
no
see.
problem.
So you should be able right now to
Yes,
see my screen. Okay. So
yes, I can.
let me maybe explain the system which we have. This is, and you had Viktor here. So Viktor created an amazing workshop for the sequence of getting the data from a crypto API and then transforming the data with Apache Flink, storing the data in Tableflow in Iceberg, and then making sense of the data using DuckDB queries. So if I will show that step by step, it starts also, this is kind of obviously the use case which we discussed, and any production system will have a lot of different sources of information coming from the outside world. There will be like databases, APIs. It will be, again, a web of complex things. Here,
Yes.
you can see right now the connectors page, right, on my screen.
Yeah, yeah, I see it.
So here, what we are getting a bit more simplified picture. We have a connector. This is from information from CoinGecko. They have amazing API.
APIs.
So, and with that API, there is this HTTP source connector. And in Apache Kafka, the beauty of Apache Kafka ecosystem is that we have so many different connectors that we can consume the data from different data sources, databases, APIs. This is HTTP, so we have CoinGecko API. At this moment, luckily, they allow using a bit of their data without actually going even into registration. I'm so
Yeah.
grateful for their stuff. And we just, this is again, I'm not a crypto person, but this is amazing source of data. We ask for the prices on variety of different cryptocurrencies, and we provide some information. This is parts which goes into the request. So here we say which cryptocurrency we want to have. We say that it should be in USD and other things. And we start getting the data into Apache Kafka topic. So we start streaming. That connector works while I sleep, and we are getting the data. Let me show you maybe an example of that data. So we get a message which contains information on different coins, some details on there. And now we can do some analysis. That analysis, we can do a variety of different things, but we start by like so this message which we get, it has several items in the same. So it has multiple coins information within one single message. It's okay to grab that information, but if we want to make sense and kind of analyze, we want to separate this. We want to do what
Split the yeah.
yeah, and Viktor called it explode. So we split the data into chunks. For this, we need to use some kind of a processing engine. Kafka streams would be an option, but here we use Apache Flink. I really like working with Apache Flink. Let me show you where I have
So basically, we have until you get things up and running. So basically, we have the Kafka Connect, the data source, which is an API that we want to pull the data from, and Kafka, and sitting in between the Kafka Connect ecosystem, which working on the concept of workers, whereby we can plug in a source connector and sync connector. So this connector would be getting the data from it will act as a source connector that get the data from the HTTP API and push it down the stream to Kafka. And on the other hand, you will show us how we can use on the other side from Kafka, how we can use Flink to process the data and come up with the shape that fits the business at the end.
Yes, exactly. You described it pretty well. So we bring the data into the system. Like with our e-commerce solution, which we discussed before, user purchases would generate us data. So we have some kind of source of data in all data-driven applications. So here in these particular examples, just for the sake of really nice, lots of nice data, we use the crypto prices. So we use Kafka Connect to stream the data into our Kafka cluster, into a topic which is called crypto prices. Now that we have initial set of data, we start processing and maybe massaging the data and making sense out of it according to what we want to achieve. And we want to analyze the trends, we want to have alerts, we want to just have a good usage of this data. And for this, for example, based on the data, we can do that separation. We use the operation union all. Generally, we just separate our Bitcoin data from Ethereum data, all of that, and send that all into a new topic called crypto prices exploded. So this is a sequel. This is a sequel which gives information to Flink to process the data. With Flink, we can work with SQL. We can work with. We can use Python. We have different levels of Java. We can different levels of how we process the data. SQL is very probably is like the highest level where all the optimizations which Apache Flink does behind this command, we don't have to overthink it on our own. That's why SQL is very like friendly and maybe a good entrance point for people who want to adopt Apache Flink, because Apache Flink is like very powerful, but also the learning curve can be a bit tough at start. Like once you get to know, it's easier. But yeah, so we have that new topic for the exploded data, and once we have that exploded data, now it looks like this. For example, we have the coin ID is Bitcoin, and then we have the value. So we only have information for a single coin over here. So we have those messages. We are getting that information, and we can make some interesting things. So we, again, using Apache Flink, we create scripts SQL queries to detect some trends For example, what is happening, trend direction based on the data. So we compare the items to each other, and then we can see where the movement of the data is happening. Then what else I have here? Some price alerts, like if the price of the next value is significantly bigger than the previous one. Here it's not. For example, here we just say it's kind of more or less the same. So we have the data. Flink help us transform what we have and create and bring it to again to Apache Kafka. With Apache Flink, we can work with other sources of data. In this ecosystem right now, I'm using only Apache Kafka and Flink. But
Okay.
yeah.
Sorry, continue.
Yes, and once we have the data, so it streams through Apache Kafka topics, but we want actually also to use it for analytics, and that's why we move it to Apache Iceberg. At Confluent, we have this amazing system feature which is called table flow, which actually behind the scenes will move the data without overwhelming brokers. It will move the data into the Apache Iceberg structure so that we can query it.
Okay,
And
but before moving to before moving to Iceberg, I have two questions. The first question is: Flink is a standalone server or components that's totally independent from Kafka when it comes to things from the architecture point of view, as Kafka Connect is totally independent component outside from Kafka. So we have Kafka as the standing at the heart of the system. The Kafka Connect is pushing into Kafka, and the Flink is streaming this data from Kafka, doing the magic and the SQL magic, and pushing it back to Kafka in a separate topics, right? Or new topics or downstream topics, right?
yes,
And Tableflow here, it's Confluent product. However, does Flink support pushing data to Iceberg?
it does. It does. There is
Okay.
different ways how you can move the data from Apache Kafka into Iceberg.
Yes.
And there are connectors from the Apache Flink side, for example. Apache Flink has a possibility to push the data to Apache Iceberg. There is a Kafka connector. There is a possibility to do it, I think, with Spark. So the
Yes.
varieties of things how you can do it. You have options for those
Okay.
who actually have their own Kafka cluster. When if they run Kafka cluster, they run also Apache Flink on their own. They can consider those options. There is some challenge how to make this happen because you want to read the data from Apache Kafka and then store it in Iceberg. You want to do it in a way that it doesn't slow down your brokers. We don't want to overload the brokers when moving this data. Then there are limitations right now. I don't remember out of my head. Even though I think I was talking about this a couple of months ago, but it's like there are some limitations of each of the libraries, or each of the approaches which you use
Mhm.
to move the data. So you need to be, for those who plan to do it on their own, they need to research also the limitations, how to move the data
Okay.
using those technologies. Yeah.
Okay. Okay. So now we have the explode function worked or explode SQL script worked and push the data to the coin prices underscore exploded. What's next?
So yes, so I showed those. I have more like, for example, this was the script for crypto trends, and I have those. So now that we have data in Apache Iceberg, we can connect. We can connect different engines and start making sense out of the data. We can even not in this demo, but I have some other I tried use cases where we can visualize the data, for example, with Elastic, or like using Trino as an engine and connecting Elastic there, or some other tools. But in this example, I have right now DuckDB. And DuckDB, with DuckDB, I can retrieve the data. So this is just like getting the price alerts. I don't actually like the whole price. I'm observing this over the past like days. Generally, I never really have really like real alerts because the change is more or less like smooth. Um, then we also can do something. This is actually relates to machine learning and to statistical models. We have a model, ARIMA. Karim, have you heard about ARIMA model? Statistical model.
Yes. I know, but it's I remember it from the when I studied in the statistics when I'm in the college, but I can't recall that I used it in the real life scenarios.
It's actually pretty widely used. It's interesting model. It has a lot of mathematics behind it, and with that we can try to predict future values using the past values. And for example, in this particular query, I'm relying on these predictions which we are making using ARIMA model, and then we see which chunk of the data actually didn't align with our prediction and which chunk of the data aligned with our prediction. So, for example, and it's not exactly anomaly in this particular use case, but this is the way how we having the data. Imagine like CPU consumption, and then you want to see where that CPU consumption becomes an anomaly. So where we, for some reason, start having higher consumption or lower, comparing to the trends which we had over the previous time. And ARIMA is one of those tools which we use. Statistical models, they are quite powerful. They are also a bit easier to understand the logic behind them if you need to understand the reason or like test, because they have mathematics behind them, versus machine learning. A pure machine learning, like it's a bit of a black box.
Yes.
We use both. We use ARIMA as a statistical model, but we put some features of machine learning around it. But in general, here we have, it looks boring data, but we kind of see that, for example, this value was actually an anomaly in the context. And ARIMA compares, it has to be like, it gets some training on the data. So first we get this real-time data. The statistical model trains on the data, and once it's ready, it starts making those predictions, and finding like, either you can use it for approximating what will happen in the future, or you can use it to approximate and then compare to the real value to find where there is a bigger difference, and then what is actually potentially can be an anomaly.
Okay, nice. So again, getting back to the flow. So we have two SQL engines here, which is Flink that push the data to Kafka, and DuckDB that reads data from Iceberg after the data is being streamed from Kafka to Iceberg. Right? Okay.
Yes.
And DuckDB is one of the, from my perspective, is one of the best and the most easy or the easiest query engine that's coming very, very fast and very strong nowadays as a query engine. And there are lots of speculations around it. I'm really excited about maybe the coming year for DuckDB. I think it will make a huge change. Do you agree or? you have other.
I agree. I must admit, I am catching up with how amazing DuckDB is. I didn't use it extensively in the past, and I feel that I was missing out. So, so yeah, you are among many, many people who actually also like tell me like the DuckDB is really, really
Yes,
amazing technology. So I need to invest more time into switching to DuckDB instead of
same
all
here.
other engines.
Same here. Okay, so Olena, I think we approached to the end of our session today. Do you have any kind of bottom liner for the session today? Advice that you were aiming to share but didn't get the chance. So the floor is yours.
Um, I believe that we talked about very important things, and those mistakes which engineers do when designing the systems. And I wanted to maybe reiterate and repeat that understanding the holistic picture of your system, of your architecture, and following the business to inspire how the data should be modeled, and how the data evolution should be made, plus not forgetting the basic tools, basic for maybe for us but not for everyone, such as schema registry, governance. Those are key success, and maybe also not over engineering stuff but still using those important building blocks to build a good foundation. That's where I believe those who either starts or want to improve their experience with data streaming should go and yeah, should use those. Oh, you unmuted, Karim.
Yes, thank you. One more last question I used to ask my guests, but I won't close without asking it. So, where do you see the AI hype standing in beside or against the data engineers, the data architects, the yeah,
I think that AI becomes so no, it's actually opposite. The data streaming is actually quite relevant to AI, because when we want to build agents which make a meaningful work or meaningful functions, they need to have access to data which is on point for that particular operation. So they need to be able quickly to gather that maybe real-time data or some other contextual data to make those decisions. And right now, like we have agents, they have the tools, but the data part is essential. So AI hype will not go far from us. Actually,
it's with us, yeah.
yes, even with my skepticism in general to putting AI everywhere, um, I do believe that AI needs contextual information and needs data streaming, and needs for many use cases it needs some kind of real time data to support those decisions which are made with AI. So I'm really curious to see how this evolves, and yeah, I'm pretty excited actually about this direction.
And for the the developer life or the dev advocate or devrel, uh, will AI the what they call uh, the question that's surrounding all the internet, will AI replace software engineers? Will replace data engineers specifically? Where do you see AI stands from the development perspective?
I believe AI will not replace data engineers. However, it makes right now we are also at the stage of AI, and we don't know what will be tomorrow. But what really hurts me right now is to see how AI affects those engineers who just starting their journey, and how unfair actually this all is. I don't believe that companies can replace engineers with AI. They are trying to automate more things, and even like use vibe coding for writing. But then we see also issues arising with vibe coding, ignoring the rules, and we need to find a way how we actually educate the next generation of engineers. um, um, yes, and I do hope that in some time companies are kind of like get back to understand that actually humans is the
Yes,
most important asset to the company,
yes,
not
yes,
those
yes.
machines. Yeah.
I agree, and I think it's for those young engineers, it's really hard for them to cope with the learning, understanding, and the hype happening. That's why I always mention to uh, whoever I work with or in the mentorship sessions or whatever, make sure that you understand the basics quite well. You have the grasp the concepts very solid, standing on a very solid ground when it comes to the concepts, and make good use of AI. Back then, in 10 or 15 years, we don't have these tools to to make learning easier like now. So make good use of it to learn you on understanding the concepts, make complex things easy instead of just asking him to write you a bunch of code, lines of code, or building you an application. So beside this, make sure that you're understanding the concepts quite well.
Exactly, exactly. As a tool, AI is amazing. We like this is such a huge change. I mean, we had calculators in the past, and I remember at school it's like, oh, you're not supposed to use calculator because I'm pretty old. So like
Yes,
because you should be able to do it everything manually. Then we had
yes,
Google. It's like, and then it's like, oh, but if you ask all the questions, Google or Stack Overflow, like what? Now we have totally different level, and I think
yes,
we shouldn't dismiss those tools because those tools are very essential for us to be more productive, to learn faster, and they open a lot of new possibilities. It's sometimes still frustrating because they also occupy our head more, and it's just sometimes I feel there is this fear of missing out because
yes,
you try to dive into one technology, and then there is so many things popping up, and then you start jumping, and I think it requires more and more discipline, which is a very limited resource. However, I totally agree with you that those tools help us, and if we find a good productive way of using those, um, and we have to do that because there is no other way around it.
yes. So I really appreciate your time, Olena, and I'm so happy having you in my podcast, and really looking forward to maybe a second session soon. I hope you enjoyed the discussion. I wasn't so hard in my questions. Thanks for the audience, and yeah, thanks, Olena.
Thank you, Karim. Thank you, Karim. It was amazing. I really enjoyed the challenges, the conversation, and I think I also learned some new things. And yeah, looking forward to do it again in the future.
Hopefully, inshallah. Hope. Okay, yeah. Thank you. Bye bye.
Bye.
Bye, Olena.